to cluster a single recording session in VoICE. Prior to running this video, you should already have MATLAB installed, and you should launch MATLAB version R2013A. Since VoICE has already been installed and added to the system path, all you need to do to launch VoICE is type the word VoICE at the MATLAB command line, and it'll launch the VoICE welcome screen. This video will cover clustering a single recording session, and then in the next video we'll cover the comparison between two recording sessions. So hit cluster a single recording session. And it'll bring up this similarity module window that I'll just make a lot larger so that it's easier to see. So we'll select a syllable table. And then we'll navigate to the VoICE folder and go to the sample data folder. Here we need to have the folder set up so that there is a .xls file and then WAV files. The .xls file must be a feature batch prepared using Sound Analysis Pro, and then the .wav files in the folder need to contain the data that was used to prepare the feature batch in Sound Analysis Pro. If you're unfamiliar with Sound Analysis Pro, please see the README for VoICE on the GitHub site, and it will take you to Sound Analysis Pro's website that you can use to prepare files such as these. For the purposes of this example, I'm going to use yellow119_small.xls, which is just a pared down version of yellow119.xls. The reason why is the small version contains fewer syllables, and thus the analysis will run faster for the purposes of this tutorial video. I suggest you use this as well, but once you're familiar with the analysis, it might be a good idea to go back and try it with the full version and see how that compares to what we do here. So I'll select yellow119small.xls, and I'll hit open. And then it'll tell me the current syllable table is that file. Next, I'll hit cut WAV files, and it will go ahead and walk through that feature batch and cut the WAV files out so that it can work on them. Next, we need to score similarity between those WAV files, and so I'll hit the Run Similarity Batch button. And when I hit that, a message will pop up saying that your similarity batch is running. It'll tell you that it might take a while, and that a status bar will spawn in MATLAB Desktop. What's happening is that VoICE is running a similarity batch between all of those WAV files. The more WAV files you add, the longer the process will take. At this step, if you have the parallel processing toolbox installed in MATLAB, the analysis will be sped up by however many times you have processors available in your computer. For the case of most modern laptop and desktop computers, this can speed it up between 4 and 8 times, which is a significant time savings. The progress bar will begin moving across the screen, and that will tell you when the similarity batch is completed. Once the similarity batch is completed, the button here turns green, and then the status will tell you that the similarity batch is complete and it's ready to cluster. So the next step is to cluster the syllables. And so we'll hit the Cluster Syllables button, and it will tell you that a status bar will spawn as it clusters the syllables. As we can see over here, our status bar is spawning, and this progress bar will tell you the process or the progress as it clusters the syllables. And so we'll go ahead and wait it out, and I'll fast forward the video and then check back in once it's complete. Okay, so once the status bar goes away, the clustering procedure is complete, and we can move on to determining the merging threshold. So I'll hit that button, and it'll launch this Determine Merging Threshold window. I'm going to go ahead and minimize the similarity module just to get it out of the way. Now what this is showing you is information about all of the possible numbers of syllable ends that we can have using VoICE. And by n, I mean the number of different syllable types. And so that's what's plotted on this curve here, where the y-axis represents the cluster n, and a cluster is a group of syllables. Here is 1 minus the merging threshold for the hierarchical clustering. If I have the merging threshold set at 0, that means that it'll be the most divisive and create the highest number of syllable types. As I relax that merging threshold, I see that the cluster n becomes smaller and smaller, indicating that it's allowing more variability in the cluster, and thus it does not divide the syllable types. For the purposes of this example, we're going to choose the merging threshold of 0.05. In addition, at the top of the screen, it'll show you a merging threshold and then information about the clusters that are created at that threshold. For example, if we scroll down to the bottom and use the threshold of 0.99, which corresponds to having 2 clusters as shown down at the bottom of the tree trimming curve, I'll have a black cluster with an intracluster global similarity of 50.0183 and 21 syllables in it. I'll have a blue cluster with an intracluster global similarity of 51.2715 and 6 syllables in it. If I raise that threshold up to 0.95, the black cluster becomes more similar to itself in terms of intracluster global similarity because it loses some syllables. The blue cluster does the same thing, and then we see a brown cluster appear, which wasn't present at the 0.99 merging threshold, and it gives you information about that cluster. And so as you increase the threshold, you get more clusters that are more homogeneous and smaller in size. It's up to you as the user to decide the correct cluster n. And that can be done by choosing thresholds and looking at the clusters that come out and seeing if there's been inappropriate splitting or merging of clusters. And so for the sake of the example, as I said, we'll use 0.05. And so I choose that threshold, and then I hit generate clusters. And in the background, some processing will occur to make the clusters for you. And a status pop-up will say that it's generating the clusters. Next, it'll tell you it's done. The button will turn green, and we'll hit reassign syllables. And that launches a new module that then shows you the clusters. And so each cluster here is represented by its own spectrogram, where each syllable in the cluster is present based on how you define them when creating your feature batch. The reassign syllables module is very powerful, and it allows you to exert control over how the clustering ultimately is completed. And so this is where we evaluate, did it do a good job of creating the clusters, or did it inappropriately merge them or divide them? And so to me, this looks pretty clean. But let's show an example of VoICE doing a bad job of merging the clusters or dividing the clusters. So we'll go ahead and close it. And let's switch the threshold to 0.99 and then hit generate clusters. Then we'll hit reassign syllables. And what happens is that I wind up with only 2 clusters. And I can see from looking at them that these are obviously not all of the same syllable type. And so in this case, it's merged a whole bunch of clusters together into the blue cluster, and it would require a lot of work on our end, plus exertion of our own biases when dividing this cluster. So we think this is a bad job. So let's go ahead and close reassign syllables and go back to the 0.05. That looked pretty good. So we'll hit generate clusters again. And then we'll hit reassign syllables. And so when you're in the reassignment module, you can exert control over the clusters. And there's one obvious thing in here that looks out of place, and that's in this cluster. For me, it's called brown. For you, it'll perhaps be named something different because the colors are dictated randomly. This syllable right here doesn't look like it matches up with the other three in the cluster. So what I can do is I can move it, and I'll use that as a means of illustrating some of the functionality of the reassignment module. So I can click on the syllable, and then I can find out some information about it. So at the very top, there's a button that says Get Syll IDs. Each syllable is named numerically, and it corresponds to the WAV file from which that syllable came. So when I hit the button, it tells me the name of the syllable down in the status pop-up, and it says it's 1. And so what that means is, if we navigate to the folder that contains our sample data, I can figure out what syllable that is. So I'll go to Voice, and then Sample Data, and then I'll go to my Voice Results folder, and I have a folder of cut syllables, and the syllable I have selected corresponds to 01.wave. That's the Get Syll IDs button. If I want to move this syllable to an existing cluster, I would select it, and then choose from the dropdown the name of the cluster that it'll go to. At the start of each cluster spectrogram, there's a word that represents the cluster color. And so if I decided that this syllable should go to the yellow cluster, even though it doesn't look like it's a good fit at all, but just to illustrate, I'll say move this syllable to the yellow cluster, and then I'll hit reassign. And this will take a second because it's reprocessing all of the clusters. It'll close the window, and then it'll launch it again, and now we'll see that the syllable we just selected is now in the yellow cluster, and it is no longer in the brown cluster where it originally came from. But obviously it doesn't look like it fits very well in the yellow cluster, so maybe we should try to find a different home for it. And unfortunately, it doesn't look like it has a particularly good home, so this might just be a syllable that needs to be its own cluster. And so in that case, I would again select the syllable and then go to create a new cluster. And so it'll list a whole bunch of colors that haven't been used, and you can pick your favorite color shade. I'll say dark orange, and then I'll hit reassign. When the reassignment module launches again, we'll see that we now have a new dark orange cluster. It contains only one syllable, the one that we reassigned. And then all the other clusters look pretty clean. But to illustrate some of the additional functionality of VoICE, we'll go ahead and do some subtyping. So, for example, let's see if there are subtypes in the blue cluster. A subtype would indicate that there are two very similar but distinct syllable types that are being grouped together. And so if I look at the blue cluster and think, maybe there are two distinct syllable types in the blue cluster, I can go ahead and try to find that. So we go to the Find Subtypes module, and then I select a cluster, and let's say blue. And then I can ask it for a number of subtypes that are in the cluster. Now there are 11 syllables in the blue cluster, and so ultimately I could break this into 11 individual syllable types. But let's just say, let's find 2 syllable subtypes in there. And so I'll select 2, and when I hit go, it will take the blue cluster and it will split it into 2 distinct cluster types and make those separate. So we'll hit go. And now we'll find that the blue cluster no longer exists. And it has been replaced by the white cluster and the Alice blue cluster. And so let's say that I wanted to undo that. let's say that I decided blue actually should be together. I'll select all of the syllables in the Alice blue cluster, and I'll move them back to the white cluster using the reassign to existing cluster module. And then I'll hit reassign. And now the formerly blue cluster is now named white, but all the syllables are back together. Lastly, there is the delete syllables button, and this is not a button to press randomly. If there's a syllable in there that I want to get rid of because I don't think it belongs, or it's a mistake that I made in creating the feature batch and I would just rather get rid of it altogether, I can select that syllable and then hit delete syllables. It will remove it completely from your analysis, and thus be sure that you want to delete it before hitting delete syllables. But let's say I want to get rid of dark orange, or whatever this cluster has been named in your analysis. I'll select the syllable, I'll hit delete syllables, and then a pop-up warning you that you are about to delete all of the highlighted syllables. Recovery after deletion requires a lot of effort. Are you sure? And if you are sure, go ahead and hit yes, delete syllables. And then VoICE will begin processing this. And it will relaunch the window, but this time the dark orange cluster is gone. And it's very difficult to get it back. So be sure before you delete syllables that you actually want them gone. But after that, I think that these clusters look pretty good. And so I think we're done and we can talk about the results. So I'll hit the No More Changes Done button, and some processing will occur in the background. And then the window will close and your analysis is complete. You can then close the determinant merging threshold, and you can close the similarity module that I had minimized. Now let's hide MATLAB, and I'll show you the results. So if we go to the VoICE folder and then to our sample data, and then into our VoICE results folder, we'll have some information there, and I'll explain what each of these are. At the bottom of the list here are two R data files. These are the workspaces that VoICE uses in the R programming language for matching and managing all of your syllables. When you delete a syllable, it saves the original workspace and then creates a new one with your deleted syllable gone, which is what happened when we deleted the syllable in the dark orange cluster. It'll also create a cluster dendrogram as a PDF file, which I'll show you here. And what this shows you is a dendrogram where each leaf on the tree represents a syllable, and then the height represents their relationship to each other in terms of acoustic similarity. The color blocks beneath are how the algorithm that prunes the tree grouped the syllables together. And then the merged color block below reflects how we may have changed the syllables in reassignment. For example, this blue and turquoise cluster were split apart when we originally had the computer trim the tree for us. After the reassignment module, we grouped all of these guys together into the white cluster. And then all of the other clusters stayed the same. So this is just a graphical representation of what happened with your clusters. When we scored similarity between the syllables, we created these similarity batch.mat files in MATLAB. This is just MATLAB calculating the acoustic similarity between the syllables. There's an _orig.mat file, which is the original similarity batch. And then there's a similarity batch completed without the _orig note on it. And this is the same similarity batch, just with our syllable that we deleted from the dark orange cluster gone. These similarity batches are also saved as .csv files, which you can open in Excel or any other text editor to look at the actual similarity scores between the syllables, if that's something you're interested in. Lastly, a syntax_summary.csv file is created for you, and I will open that in Excel to show you what happens with that. This syntax similarity file contains a transition probability matrix, which I'm highlighting here. Rows in here are named for clusters, which are the individual syllables, and columns are named for the clusters as well. You read these by looking at the probability of the row cluster transitioning to the column cluster. So, for example, the white cluster, whenever I saw a syllable that wound up in the white cluster, 63.63% of the time, the white syllable transitioned to another white syllable. 27.27% of the time, the white syllable transitioned to a red. Whenever a red occurred, 100% of the time it transitioned to a black. Whenever a black occurred, 100% of the time it transitioned to a green, and so on and so forth. We also calculate some metrics, which are described in the manuscript for VoICE, to determine how stereotyped this transition behavior is. And so we get a entropy and stereotopy score, and then a weighted entropy and weighted stereotopy score. You can read in the manuscript what the differences are between these scores, but they're both ways of describing how stereotyped the syntax is. We'll then close syntax summary. Lastly, there are sorted clusters and sorted syllables and joined clusters that contain wave files for your individual clusters. And so just like MATLAB was showing us wave files of all the syllables stitched together, it also creates these files in the background for you to look at. And so you can open them in a sound editor like Audacity and just view the clusters to make sure that they look the way you think they should. And these also correspond to those colors on the dendrogram that were created here. So this is just for visual inspection. And then the sorted syllables are, again, sorted by cluster. And this time, they're the individual syllables that are stitched together in the spectrograms that we just opened in Audacity. The cut syllables we've already been over. It's just the individual wave files. And remember, when you delete a syllable, like we did in the reassignment module, that syllable will be removed from the cut syllables folder. And then lastly, the cluster tables exist. And these are where you get the data that you would probably do statistical analyses on if you're interested in the acoustic features of sound. And so for the black cluster, brown, green, red, white, and yellow, there are CSV files containing information about the syllables in those clusters. And so if we open one of them, in this case we're doing the black cluster, and your colors may be different from mine, but they all should contain the same information, it will, on each line, contain information about a syllable in the cluster. So for example, in the black cluster, syllables 10, 16, and 22, which if we go to our sorted syllables folder and then look in the black folder, we see 10, 16, and 22 are the wave files in the black cluster. We get information about those syllables. And so these columns each represent acoustic features of sound, so the duration, the syllable start and end, the mean amplitude, pitch, frequency modulation, amplitude modulation, and so on. Cluster tables. And so those are present for each cluster. And this is a single recording session. And so now you have information about the sequence stereotopy of the syllables and the acoustic properties of the sound. What we'll see in the next video is how you compare one session that's recorded after this one to this current session so that you can make a before and after comparison, such as before a treatment, like we've clustered here, and then after a treatment, like we'll see in the next video, to see if your treatment has an effect on the sequence stereotypy or the acoustic properties of the sound.